Hello my dear students, welcome back to one more class. In today's class we are going to see titration. How titration should be performed, what all things, calculation, observation and everything I am going to explain in today's class. So do watch this video completely. So in this class I am going to explain you how to prepare M by 20 solution of Mohrs salt, and with the help of this solution how to find out the strength and molarity of a given solution. So for calculating this one here, as it is given M by 20. So students, in exam they can give you the different molarity based on internal or external choice. So what you have to do, the molarity which have which is given in the exam, only that molarity you have to use it to do calculation part. So here as it is given M by 20, so what you are going to do, M by 20, like if it is given M by 20, or they may give you like M by 30, M by 25, M by 45 or M by 50. So how to prepare Mohr salt for that? What we are going to do, we will be just using one formula. With the help of that formula we can calculate the amount of Mohr salt required for any molarity. So which is the formula is molarity is equal to weight in grams upon molar mass of a Mohr salt. So if you will do remember this formula, easily you can calculate the amount of salt which is required to prepare the standard solution into 1000 upon 250 ml. In today's experiment, I am going to explain about 250 ml. Students, if your teacher or external ask you to prepare the solution in different volume, so you can place the value of that volume here as on 250. For example, if your teacher said you to prepare the solution in 100 ml, so we'll be putting this value here as a 100 ml. I am calculating it for 250 ml. As in my question it is given M by 20, so I am writing here it as a M by 20. So you can also write the given value. If it is this value is given in decimal like 0.05 or 1 by 30 or 1 by 25 or 1 by 50. So whatever molarity is been given in the question, that molarity you are going to write here. Then weight in grams, it means x, so this value of x will be calculating. 392 would be the common for all the molarities, and divided by into 1000 upon 250. If it is a given volume, that volume you will be calculating and then writing. So here the value of x is 4.9 gram. So I have calculated the value of x. X, it means this much quantity of Mohr salt will require to prepare 1 by 20 molarity solution of Mohr salt, and with the help of this solution we will be calculating the molarity and strength of the given KMnO4 solution. So now I will be explaining you that how to prepare, how first of all I will be telling you how to prepare Mohr salt solution, and then I will be telling you how to prepare standard solution. So here students, we have this weighing balance. Electronic weighing balance is available in all the school, in all the laboratories, and I took the one watch glass. Here is the ammonium ferrous salt sulfate, that one is a Mohr salt. I took out this Mohr salt in china dish, and here is the balance. Now what you have to do, first of all you are going to press the button on or off. Then as soon as it is coming 0.00, then just make it a 0 or wait for some time, and then place your watch glass over there and note down the value of watch glass coming here, and then make it as a 0. Just press the button as a 0, and then as we have calculated amount 4.9, so let's start pouring the salt on that, and we will get the 4.9 gram of the salt. So in this manner you can measure the salt which is required for preparation of standard solution. Student, in your laboratory they can be a different electronic balance, so just you can discuss with your lab attendant and can discuss how to operate that. Here in my electronic balance, it is very easy to take the amount of 4.9 gram. So here I am taking amount as a 4.9 gram, and then let's take the exact amount as a 4.9 gram, so which we are going to use it for our preparation of standard solution. Students, see, while measuring this salt, I am taking precaution that we should get the exact amount which is required for our titration, and you have to do little bit weight, and then you will observe that this will come exactly as a 4.90. As soon as you will get the value as a 4.90, and then we can start with our practical, right? We can start preparing our standard solution. So here we got the salt, and the weight of that salt is 4.9 gram. Now what you have to do, we will be preparing standard solution. So here we have, this is the standard flask which we are using it for the preparation of standard solution. And this every flask is having one mark, and this flask is of 250 ml. In calculation also we took it as a 250 ml. So, and this funnel we will require for the preparation of the standard solution, concentrated H2SO4 and wash bottle. In this white wash bottle I took water. Now what I have to do, first of all I will be taking a funnel and keeping this funnel on the standard flask. After keeping the funnel on the standard flask, I will be pouring this salt to it. Be careful while pouring this salt. Add a small quantity of salt first, and then you can pour the complete salt. After pouring it, just shake a little bit this funnel, and then the complete salt will get down in the standard flask. Then you can see that here some salt is still sticking on the watch glass. So with the help of wash bottle, we will be transferring a complete salt into the standard flask. Now after this, add 2 to 3 drops of concentrated H2SO4. Here we are pouring concentrated H2SO4 to to prevent hydrolysis of ferrous ions to ferric ions. It is very mandatory step, otherwise your color of the standard solution will turn to brown. After this, what we are going to do, we will be pouring a very small quantity of water to this flask, so salt should get dissolved in the water properly. So after, you can pour the water in this manner, so if any sticking particle are there in on the funnel or on the watch glass, so those can be easily added into the standard flask. So I added a very small quantity of water into it, then I removed the funnel, and then I am just dissolving this salt into water. The first thing is that you all have to dissolve the salt into the water carefully. After dissolving salt into the water, what you have to do, you have to make up the volume up to 250 ml. So for making up the volume up to 250 ml, on every standard flask, one mark is given always on the neck of this flask. In this on this flask, here you can see that here mark is given, so I will make up the volume up to that mark. When I will make up the complete volume, then this standard solution will get prepared. So what I am going to do now, I will be pouring a water. You can use a funnel always, so it would be easy for us to pour the water, and water will not get spilled off, right? So what you have to do, we just pour the water till that mark. So be careful while pouring the water. Above that mark it should not reach, and that's why, see, I am slowly I am pouring the water in it to get the exact amount up to 250 ml. And then this standard solution is considered as a standard solution of Mohrs salt. Here you can see that exactly up to that mark we have done with the preparation of salt plus water. Right? Now in the next step, we are going to study how to do the next procedure for titration. Now what you have to do, children, first of all, set up all your apparatus carefully. In this apparatus, that is, this one is the buret. In the buret I am pouring KMnO4. So you have to pour the KMnO4 carefully. After pouring KMnO4, you will see that from the jet of that KMnO4, it means from the lower part of that burette, the jet of burette, you have to run down the KMnO4 solution and then remove your funnel. In this manner you will be filling your burette with KMnO4, and then we have prepared the standard solution of Mohrs salt. So this one is known as a pipette. So pipette, we are using it for preparation for taking out the salt solution. Either you can use this pipette or this measuring flask. Okay, anything you can use it. So now first of all I'll tell you how to use this pipette. So you can just insert this pipette into that standard flask and then start sucking out the solution as we are sucking the juice from the straw. And on every pipette there is one mark, so you have to run down the solution up to that mark. This is actually a practice procedure. When you will do it properly, when you will have a practice, you can take that solution exactly up to that mark and then transfer this solution into a small conical flask, which will also known as a standard flask. So this is the one method to take the 10 ml of standard solution. Another way, if you don't want to use the pipette, you can use the measuring cylinder also. In a small measuring cylinder, just pour 10 ml. Measuring cylinders, all marks are there, so just pour the standard solution into the measuring cylinder. After pouring it, then you can transfer it into flask. As I have already taken with the pipette, that's why I am not taking another time. Now student, very important one, 4NH2SO4. 4NH2SO4 solution also you all have to take one test tube, because this 4NH2SO4 solution is providing acidic medium to KMnO4. So I am pouring one full test tube of 4NH2SO4. Just pour that one test tube and then let's start performing experiment. Now for performing this experiment, what we have to do, we have taken already the standard solution, we added 4NH2SO4. Now what I am going to do, I will be keeping this below the burette, and then I'll start pouring the solution from burette to this conical flask. And you will observe that as soon as I will start pouring it, the color will change, but when we'll start swirling it, color will get disappear. The end point of this titration is from colorless to light pink. So first of all you will be pouring the solution exactly about 1 ml, and then you will get to know that what will be your first reading. As soon as your solution will turn from colorless to light pink, you can stop this practical there only. While adding this one, beta, please be careful that your solution should be light pink, as it is the first time you don't know where the point where the exact reading will come. That's why it is little bit dark, but I will show you one more reading in which in which you will get the exact light pink color. So as I told you that, as you can do this experiment with measuring cylinder also. So I took the standard solution in the measuring cylinder and I just transferred this into titration flask. Then again the same procedure I am repeating. Take 4NH2SO4, which will be already be prepared in your laboratory. Your teacher will provide this to you. So full one test tube you can add this into the titration flask. After adding this solution into the titration flask, we will be doing the same procedure. Now the second time, what you have to do, first of all, either you can fill it up to 0 mark, or you can start from there only where you have stopped after first reading. Right? So if you are starting from here, then this one will be your initial reading. Now I am not filling it again, so that will be the initial reading, and then I will again do the same procedure as I did for the first reading. I'll start pouring the KMnO4 into the flask, and I'll at the same time I'll do swirling of this titration flask. Then after some time you will observe that again I will get the light pink color. This time you should be very careful, because first time we got the dark pink, but the exact and the correct reading is the light pink. So I'll show you which one is the exact and correct reading. If you will do it in this manner, your result will be accurate, and after taking the reading you can show this result to your internal as well as your external teacher. Right, so while doing it, be careful. Start adding the dropwise solution. When you will add the dropwise solution, it would be easy for you to get the exact pink color. See, you have to be patient while doing this titration, because we want the color and that should be light pink. An extra drop of KMnO4 can change its color to dark. So as I am taking the second reading, so I will show you the exact light pink color. So student, you can see that there is a difference between both the color, right? This is the first reading which is quite dark, and this is the exact reading which is absolutely correct. So every time you should get this light pink color. This is your first reading, this is your second reading. In this manner you can take the second, third and fourth reading also. So student, as I showed you how to perform the experiment, so now what is the next? Next one is observation table. So while writing the observation table, what all things you have to keep in mind that I am explaining here. So first of all, you all have to write the weight of watch glass. Then after, as you have seen that how to take the weight of watch glass, that watch glass weight you will be writing it in a gram, and after that weight of watch glass plus weight of salt, that one was 4.9 gram. Do addition and write down there. So as we did the experiment, we got some reading, first reading. Now consider that your initial reading is 0 and final reading which you got is 9.8, and this is the reading of buret. Now how we are going to calculate the volume of KMnO4? We will be doing it as a final minus initial. So final minus initial, it means 9.8. So as I told you that while taking the second reading, and yes, every time you took the volume of more salt is 10 ml. Clear? Now after taking it in the first reading, what you have to do, you will be taking the second reading as well. Now it's for second time you will be starting it from 9.8, right? Now from 9.8 to whatever is your final reading where you got the light pink color, light pink color, that light pink color you will be noting down the reading here. So as soon as you will note down the reading here, you will get the volume of KMnO4, and here by calculating or simply I am writing here it as a 9 point. So here after doing minus, you can just note down the value as 8.5. So beta, here as you got the value as 8.5, then you will be taking the third reading. In third time, initial reading would be this one, and whatever the final reading you will get, you can note down there. And final minus initial, in that way you can do, and you can get the volume for third reading also, fourth reading also, right? And every time we will be considering Mohr salt as a 10 ml. Now student, what you have to do, after taking four readings, you will be finding out the concordant reading. Concordant reading, it means the reading which is out of this reading, you will be finding out concordant reading. And concordant reading, it means repeated value. Now here you got it as a 9.6, here you got it as a 9.6. So the two values which are coming quite close, you can take that value as a concordant reading. After getting the concordant reading, what you have to do, you will be doing calculation part. Here I am explaining calculation part also. Like formula is M1V1 upon M2V2 upon N1 N1 upon N2. Now M1 and V1 and M1 is for KMnO4, and like molarity of KMnO4, volume of KMnO4. And this one M2 V2 is for Mohr salt, molarity of Mohr salt, volume of Mohr salt. N1 and N2 is the number of moles of Mohr salt and KMnO4, which you will be studying it in the ionic equation, right? So how many moles of KMnO4 is reacting with Mohr salt? That one is N1 upon N2. So let's put all the values. M1 you all have to calculate, then V1 you will be putting here value as concordant reading, and then molarity is given in the question. So molarity of Mohr salt, it is given in the question, and this one is 1/20. So 1/20 we will be writing. Whatever molarity you will get, you can write that in your while doing calculation, or in your formula you can write that. And student, Mohr salt, every time we have used it as a 10 ml, so we will be writing 10. 2/10 is the number of moles of KMnO4 reacting with Mohr salt. Then let's calculate the value of M1. This value will be the molarity of KMnO4. Similarly, we can calculate the strength of KMnO4, and this one only they have asked us in this titration. So strength of KMnO4, how to calculate? First of all, we will be calculating molarity of KMnO4 into molar mass. Molarity of KMnO4 into molar mass of KMnO4. Consider that the molarity is X and molar mass of KMnO4 is 158, and you will be getting the next answer, and this answer would be in gram per liter. And these are the two answers which has been asked in this experiment. That one is molarity of KMnO4 and strength of KMnO4. So student, in this manner, if you will do your performing part and writing part, definitely you will get 15 on 15 marks in your chemistry practical. Nobody can deduct your marks for any of the thing. What you have to do, you have to carefully watch this video and then do practice of writing it. Surely you will get an idea that how to write without doing any mistake. So students, while doing it, please, you have to be careful that you should follow all the instructions carefully. I hope this video is worth watching it. Thank you students, and have a good